Hello guys, welcome to the Edupedia world. In this tutorial, we'll continue studying operators. So in our previous tutorial, we have covered assignment operators, increment decrement operators, and arithmetic operator. In this tutorial, we'll be start studying from the bitwise operator and we'll try to cover bitwise relational and logical operators. So let's begin. This is bitwise operator. So Java's bitwise operator on individual bits of integer, int and long values. So, whenever you put a bitwise operator, it is usually based on individual bits of integer which can be written in a form of a int or long. Then, if a operand is shorter than an int, it is promoted to int before doing the operation. So, whenever there is an operand that is shorter than int, it is actually promoted to int before doing any operation onto it. Okay, so these are some of the examples of bitwise operator. In first operator, we are doing A and B. So the value will be 1 if both the bits are 1. If A and B both are 1, then the value will be 1. Then we have A or B. So if either A or B is 1, then the value of A or B will be 1. Okay. Then we have XOR. In case of XOR, 1 if both the bits are different. So XOR will give you the value 1 only and only if A and B are different. So either A is 0 and B is 1, or A is 1 and B is 0, or if they are different, they are not same, then the result will be 1. Then we have a NOT operator. In case of a NOT operator, it actually inverts the bit. So if A is 1, the value it will give you 0. If the A is 0, it will give you 1. Or if it is having any other binary, like any other bit value, then again, it will invert the value. Fine. Then we have left shift. So left shift is denoted like this as shown over here. And what it does, it shifts the bit of n left p position. 0 bits are shifted into the row order position. So what is happening? It is actually shifting the bits of n left p position. So if you are doing like n is 5 and p is 2, so the value, the bits formation of 5, the whatever the bits formation, the formation in 0 and 1, it actually gets shifted by the 2 position on the left hand side. And in a right position, on a right shift, the same is happening but on right hand side. So in this case, the right shift, which is noted using this, shifts the bit of n right position. If n is 2's complement signed number, the sign bit is shifted into high order position. So yeah, if n is, it's 2's complement, means it's like a 2 complement signed number, then the sign bit is shifted into a high order position. I hope that's clear because that's usually a concept of maths. And well, again, a right shift operator. So right shift can also be denoted using this 3 of these. So what does that mean? Shift the bit of n right p position. Zeros are shifted into high order position. So if there's any 0, then it is shifted into high order position. Okay, so this is an example of bitwise operator. So what we are doing in this is, we do have a class test and then we have a method main. Inside the main method, we have created a integer a and assigned a value 60 to that. Okay, so in this comment you can see like what's the bit formation of 60. It's something like that. Then we have int b equals to 13 and this is a bit formation of 13. Then we have int c is equal to 0. Okay, and now what we are doing is c is equal to a into b. So basically, what do you think would be the output of C? So what's happening in C is, it will give you the output of A into B, like only and only if A and B are both 1. So you have to actually multiply each integer. So when we multiply 0 by 1, the output I will get is 0, because when I'm doing, sorry, I won't say multiply, I would rather say A and 1. So whenever I'm doing like 0 and 1, I'll get the output as 0, because to get 1, both has to be 1. Then I'm doing 0 and 0, I'll get the output as 0. Then I'm doing 1 and 1, since both are 1, I'll get the output as 1. Then again we are doing 1 and 1, then I'll get the output as 1. Okay, and then coming to this bit and this bit, by doing 1 and 0, I'll get the output as 0, and so on. For rest of the number also we'll get 0. So over here we only get 1 whenever we are doing 1 and 1. So this is the output that we got, and this is a bit formation for the number 12. Okay, so you can convert the bits to a number using, like, there's a simple maths concept by using into 2 raised to the power 0 up to the number uh, over here. I hope you are aware of that. If you are not aware of that, it's a simple maths concept. You will get to know by searching on a Google, like how to convert this bit formation to a numeric number. Okay, so the value is 12. So over here the value of C will be 12. Then we are doing OR. In case of OR, we'll get 1 if and only if any of the one integer is 1. So when we are doing 0 or 1, we get the output as 1. If we are doing 0 or 0, we get the output as 0. When we are doing 1 or 1, we get the output as 1, because any one of them has to be 1. So if both are 1, we are good. If any one of them is 1, then also we are good. So except when 0 or 0 is happening, otherwise everything else will give us 1. So over here, this is the output that we got, and the numeric value is 61. So A or B will give you the value as 61. Okay. So yeah, these are some of the more examples. So over here we are doing A XOR B. So what happens in XOR is we'll get 1 only and only if like A or I say 0 and 1, or whatever the values that we are doing XOR, are different. So you can see we have got 1 on the first place from this side. So let's see what was the value of A and B. Yeah. So the value was different. See, 0 and 1. Over here, same, then different. So that's why we have got like 1 over here and 1 over here, and rest of them are zeros. So the numeric value is 49. Okay. Then we are doing negate of A. So the A, which was earlier as 00111100, will now become 11000011. So every, like, 1 will become as a 0, and every 0 will become as 1 if you are putting an invert operator or a negate operator. So the value, like numeric value, will be minus 61. Okay. Then we are doing a left shift operator. So in left shift, we are shifting the bits to the left hand side by 2, and all the high order zeros, and all the zeros get to the high order. So what's happening over here is, let's see the value of A. So you can see what we are doing is we are shifting the bits to left hand side. So we are shifting these two zeros because we have to shift two bits. We are doing left shift 2. Okay, so the two bits that we have to shift, which will be this 0 and 0, we'll be shifting them to the left hand side. So the output that we'll get over here would be this. So what's happening is these two zeros that got shifted to the like left hand side. So you can see everything is getting shifted to the left hand side. So this one which was over here got started from here, and these two zeros actually got shifted to the left hand side. So it actually by default came here because we have to shift everything towards the left hand side. We have to shift everything in this direction. Okay. So this is like left hand shift. We have to shift these two zeros, and we have to shift in the left, and there's nothing on the left, so it automatically goes to this side. Okay. And these four ones which are over here will actually come and shift it to left hand side, will come over here. That's why the output of left shift to is this, and the numeric value is 240. Then we have a right shift operator. So what it's doing is it is doing the right shift. So it is actually shifting the bits on the right hand side towards the right hand side, and again they're coming in a loop. Okay, then we have right shift operator with this three like arrows, and yeah, it is again doing a right shift without that thing of a high order. So what it's doing is actually shifting the a bits to the right. So whatever is on the right hand side, these zeros will be shifted towards the right. That's what's happening over here. So I hope the bitwise operators are quite clear to you. And yeah, so it's like if you are still having any confusion, you can just try out using an Eclipse, or I think it's a simple maths concept. So you can also find it on a Google, like how the left shift and right shift actually works, because it's actually kind of a maths thing. So it is easily available. So yeah, I think we're good with the bitwise operator. So let's move towards the relational operators. So relational operators compares two values and determine the relation between them. For example, not equals to return true if two operands are unequal. So it is actually comparing two values to determine any relation between them. Relational operators are used to test whether two values are equal and whether one value is greater than other, and so forth. So what are different relational operators? So the first one is double equals to. It checks if the value of the two operands are equal or not. If yes, then the condition becomes true. So see, there's a difference between single equals to and double equals to. So the single equals to is the assignment operator. It is used to assign the value. And double equals to is actually used to check if the two operands are equal or not. Okay. So just to let you know, in case of a primitive type, if we are putting this double equals to operator, it will definitely match the value. Like if we are doing A equals to B and A and B are both 3, then it will give you as true because it is going to match the value. But you can also put these operators in case of a object. So like there's an object of a class student S1 and there's an object of a class again student S2. It could be possible that although both S1 and S2 are having, like the data members having the same values, still S1 equals to S2 will give you the result false. That's because S1 and S2 are two different objects. And comparing the objects using double equals to actually doesn't compare their value internally, because how does double equals to will know? It need to check the values of the data member. It will definitely check the objects, and definitely those two objects are different. S1 is a different object, S2 is a different object. Irrespective of the values of the data members, it will give you the output as false. Okay, so in if you're confused about that, then we'll do an example, so don't worry. Coming to not equals to. So not equals to check if the values of two operands are equal or not. If values are not equal, then the condition becomes true. So it's actually the negative of double equals to. If the two operands are not equal, then the result will be true. Okay, then we have this greater than or less than operator. So it checks if the value of left operand is greater than the value of right operand. So I hope that's pretty simple. I mean, you must have used greater than and less than sign in maths. Okay, then moving forward to left operand, the greater than sign with equals to. So it checks if the value of left operand is greater than or equals to the value of right operand. So it will check greater than or equals to. So this operator stands for greater than or equals to, and then this operator stands for less than or equals to. So if any of this condition is true, either it's a greater or it's equal, then the value will become true. Similarly, if it's like less than some particular number or it's equals to that particular number, then also the value will become true. So this is a simple example where we are just performing less than operator, where we are doing if A is less than B, A is 5 and B is 10. So it will print as A is less than B, which is true in that case. Okay. So I think the relational operators were clear. Now let's move towards the logical operators. So these logical operators works only on the Boolean operands. Return values is always a Boolean. So logical operator will always return you a Boolean value and it works on a Boolean operand. So let's see what are logical operators. Well, it's showing three of the logical operators, which is double and, which is also called as logical and. Then we have logical or and then logical not. So what's logical and is doing? Called logical AND operator, if both operands are non-zero, then the condition will become true. Okay. So as we have also studied in a bitwise AND operator, when the both operands are 1, then it becomes the output that will give you is 1. So similarly over here, if both operands are non-zero or non-false or true, then the result will be true. So, what's the difference between bitwise and this logical AND is, first of all, bitwise is only used to compare zeros and one, but over here, double AND is actually comparing the conditions. So there could be any two condition. If you are saying this condition is true and this condition is true, so the two operands that you're comparing has to be resulted into a Boolean. So you can either compare true and true and true and false. So it has to be between true and false, the Boolean values. Okay. So if both are non-zero means both has to be true. Then and only then you will get the output as true. Okay, and another important difference is in case of a bitwise operator, it will actually check for both the operands. It will actually check there is a left operand, then there is a right operand. So it will actually check for both the operands, for both the condition. It will check if both are like 1, then it will give you the value as 1. But in case of a logical AND operator, if it's checking from right hand side, this side, and the resultant operand is actually false or the condition is resulting into false, then it will skip this left hand side operand because if any of the one value is false, then the output will be false. So it's actually computing this one value, and if it comes out to be false, then it will skip and will give you false. If it's true, then only it will actually compare or will actually check the value on the right hand side. So like this is a difference between logical and bitwise and same goes for logical or and logical not, that the comparison happens from the right hand side, and if the right hand side one is giving you true, then and only then it will like go to the left hand side to check. So in logical or, if any of the two operands are non-zero, then the condition becomes true. So yeah, in this case it has to check both the operand, because if any one of them is like non-zero, then it will give you true. Then we have a not operator, so it actually reverse. So as in case of a bitwise where it was reversing the bits, over here the not operators is actually reversing true and false. If it's true, it will make it to false. If it's false, it will make it to true. Used to reverse the logical state of operand. If condition is true, then logical not operator will make it false. So I hope it's clear. Let's try to run something. So what I'm doing is I'm doing int, and then I'm doing like a equals to 5, and then I'm doing int b equals to 6. Okay, so over here I've declared two more variables, which are c equals to 7 and d equals to 7, and I'm going to compare these two also using a logical double equals to operator. So I'm going to do this. In this statement, I'm going to compare these two, and I'm going to print, what should I print? I should print like all equal by and, okay. And then I'm going to put an OR operator in between these two. So in case of OR operator, if any of one condition is true, it will give me a true result, okay. And now let me also try like a negate operator or not operator. Well, not operator, I'm checking if A is not equals to B or C is not equals to D. Then I'm printing or equal by or not operator. Oh, so over here I'm not using a relational operator directly, rather I'm using a logical not operator. So I'm using like not equals to, so it actually becomes logical not a relational operator. So okay, so the output that I've got is all equals to. So let's run it in our mind by one. So in the first line, I'm checking if A double equals to B. So A is 5 and B is 6. So these are not equal, right? And C double equals to D. C is 7 and D is 7, which are equal. So how this AND operator works, it first going to compute C double equals D. If it's true, yeah, it's true. So then it's going to compare these. So this is not true. So if one is true, other is not true, the AND operator will give us false. So this line won't be printed because the statement is not true. Then coming to the second line, OR operator, it will compute C equals to D, which is true. Since it's true, it won't need to compare this because in case of a OR operator, is any of the one condition is true, then the output would be true. So it has checked the one condition and that's giving us true. So it will print this line. Okay. Then we have A not equals to B, which is okay, we'll start from here. C not equals to D, which is false because C and D are equals, and we are saying not equals, which will give us false. Okay, this is false, so it will need to compute this thing. So it will check if A is not equals to B, which is true because A is 5 and B is 6. So true or false will give us true. So this will print this line. So that's why the output we have got is the two lines that we printed downwards that were all equals by or and all equal by or and that was all equal by or and all equal by or and not. So I hope the logical operators, the relational operators and bitwise operators are all clear. So let's cover the remaining operator in the next video.